Hi everyone, let's talk about backups, specifically terminal tools you can use to backup your data and system. If you have lost your data anytime, whether your personal files or work context, you definitely know how important backups are. And there's all kinds of tools and strategies you can use. So let's dive in. First, as a reminder, there exists a golden rule of backups. It's kind of a strategy how you can think of your backups. So first of all, keep 3 copies, one original and 2 copies, 2 media types, maybe a hard drive, a USB, and one offsite copy. Offsite copy can be also cloud. Depending on how important your data is, you might want to apply this rule. So what do we back up? Obviously, we back up our files, documents, pictures, videos, databases, whatever we have. So that's meant by data, and you probably already have lots of backups on your phone. Whether those are pictures with iPhone or Google. However, system backups are a little bit different. If you're using Mac, it's a bit easier to set up the backup. I am using Linux, and if you're watching this channel, you're probably into command line tools anyway. So there are various ways of automating this process, and most importantly, having it under your control. Another thing we want to back up is a system, whether it's a system state, list of installed software packages. We want to backup configuration, things like dot files, application settings, or more. iBackup, for example, systemd services, cron tabs, and more. And finally, you want to backup secrets. You're hopefully already using a secret manager application such as Bitwarden, 1Password. There's plenty out there. However, you also should additionally backup your secrets in a secure way. So that's the ideas of what we should back up. This is, of course, not an exclusive list, but it's a good overview when you think about what do you want to back up to start with. So where we back up to? First option, pretty logical, is a local disk. So this is for data that is not critical, because if your disk hardware fails, then of course all the backups are gone. But programs like Timeshift and others would use local disk to create quick backups. The same goes for PopOS, the system I'm using. It also has a recovery partition, which is kind of backup as well. A very accessible backup target are network drives such as NAS, Synology, or others. And if you have your own home lab, you can also those instead. So NAS, if you don't know, is just essentially a hard drive with some additional functionality that you can use as a backup among other things. So that's how I backup stuff at home, and you can have various options there. USB drive is a good idea. You can have a USB or external hard drive stored somewhere safely with very important data that's for redundancy in case you cannot access your network, or if you back up to cloud storage, which is another option, and you cannot access it, USB drive is always a good idea to have a physical copy of your data. So today we are going to focus on terminal tools. As with everything else that I've talked about on this channel, I believe that command line and terminal tools are simply better and um, more automated. Once you are done with fiddling with parameters and understand what they do, you can script those things and you can create reusable snippets that you can then later use within your backup strategy. All of those things are possible with solutions that require graphical user interface, but I believe that command line is more portable, more efficient. So we will focus today on 3 tools: Restic, Rsync, and Rclone. They coincidentally all start with R. They overlap in many cases, but they have also an interesting distinct features. And all of those tools can be run using cron. If you don't know what cron is, it's essentially a task runner that can run any script or any command on schedule. You can run stuff every hour, every day, and so on and so forth. So that's a very useful useful way of automating your backups. So you don't want to forget about running a backup script. You can set it up with cron, which is super easy. So now we're going to switch to demo, where I'll show you how to use Restic, create repositories, restoring snapshots, and so on, Rsync and Rclone. And we are going to go through a few of the basic commands. So first thing to do, let's start with Restic. So Restic is a backup program allowing for multiple revisions or snapshots of files and directories in an encrypted repository. So those two things are important. First of all, Restic creates snapshots, meaning that you can version your data as it changes. You can have every time you back up something in Restic, a new snapshot of the same data will be created. So you are getting this versioning, Git-like versioning out of the box. And then Restic also encrypts your data. This is not super amazing encryption. It just uses password. So for very sensitive data, I would suggest using GPG to encrypt the data before putting it into Restic. But for not that sensitive data, Restic is definitely sufficient, and the encryption level is solid enough for this data. So that's the introduction to Restic. Let's see what we can do with it. So the first command we want to do is to initialize the Restic repository. So you can see just an init keyword and then repo flag, and we are letting Restic know where to initialize a repository. Once this is done, we can see that this is essentially a Git bare repository. Restic requires password and a path. It so happens that I already have password captured in an environmental variable, and then only path. I'm providing only path to Restic. If you don't have a password, Restic would ask you for it. So let's see what we've done with this command. So you can see the folder here is just a bare Git repository with some additional Restic specific things like snapshot, for instance. Now we are going to introduce a demo folder. So this is just some made up data that we are going to work with to exemplify various backup tools. So in this case, we have just a demo folder right here where we are, and it has 2 subdirectories and a couple of files. All right. Let's back something up. So to back up things with Restic, we just use the backup command, provide a source folder, target repository which we've just created, and that's it. If everything goes well, Restic tells us that, yes, I've backed everything up. This is the repository ID, and then I created a snapshot of this ID. So we mentioned Restic creates snapshots, so all this folder together is backed up, and it's backed up as a snapshot. If we would change anything in those files and back up it again, Restic would create additional incremental snapshot. So now we can see all the snapshots that Restic created. It should be only one. And that's the case. We have snapshot ID here, 94 and so on. And we have timestamp and the absolute path of the folder we have backed up. What else can we do now? Let's restore everything. So very important, if you back up anything, immediately after doing so, you should exercise the restore process, which is the biggest failure mode in backups. So in Restic, restoring is super easy, just another command restore. We are giving it a source repository and a target folder where we want to restore the data from a snapshot. So we have a restore folder and the snapshot ID that we've seen earlier. So Restic says it restored it, and snapshot ID of this type of folder and timestamp, we have restored it into the restore folder. So let's see if this is the case. and we can just tree our restore folder, and indeed it has the files that we just backed up. So you can imagine with Restic, if you have data that require snapshotting or incremental Git-like versioning, it's a super interesting option, especially with things that require encryption. That gives you a lot of ability to play with it. If you are on Linux, you can use Fuse-based mount file systems, which are kind of additional file system like AutoFS or NKFS that can make it much easier to mount Restic repositories and do all kinds of more advanced stuff with it. I might make a video about it one day. If you're interested, let me know in the comments. Okay, so we have backed up with Restic and restored with it. Let's move to another tool, Rclone. So Rclone is a program that manages files on cloud storage. It's specifically designed to take files between cloud storage and your local drive and to move them around, copy them around. Very feature rich, and it's an alternative to cloud vendors' web storage interfaces, which is really cool because you don't need to log into Azure UI or log into AWS or other 70 cloud storage products. You can just manage it all from one command line and set it up. So you can take data from your hard drive and push it, let's say, to S3. We are going to do this with Azure Cloud, Azure storage account, and you can create various backup strategies, cron or other services. So Rclone requires setup that I've done earlier. You can read about it in documentation. It's a command rclone config, and it gives you a list of all the backends, all the remotes that you can set up, and then there's a wizard guiding you through what kind of data you need to provide. So I have two remotes configured, a Google Drive and Azure remote. So now let's see if there's anything in my Azure remote. Before we go to this Azure remote backup, I want to show you Azure itself real quick. So here I have my Azure account, and you can see there is an Azure resource group. If you don't know about Azure, don't worry. This is just a place where Azure services live. This resource group really wants to be deleted. And I have a storage account named Rclone Demo SA for storage account. Azure storage account is really like AWS S3 bucket, but I prefer it. You can see here I have a backup folder, which currently is empty. There's nothing here. And Rclone connects with Azure with this service, and we are going to operate on this backup folder from our terminal. Let's go back to our commands, and you can see that this folder is empty. So running the same command with Rclone should also tell us that this folder is empty. And this is the case. There's nothing here. Let's put something there. So we are going to use Rclone copy command, and we're going to grab our demo folder and move it to Azure Backup. The slight difference that you will see is that when we're done with backup and when we list the content of backup folder, it actually omitted the demo folder itself and put the contents of the demo folder. Would have to put another path to include the demo folder as well. But since we have it here, let's check if it really put the files in our cloud service, and it did. We have this source, documents, and so on. So that works. We are connected to Azure, and we can very quickly back things up to cloud. Azure, of course, it's a paid service. However, there's a very generous free tier from Azure. I happen to have Azure VS Code subscription back from the day, and I have a few renewable credits. If you're a student, I know there are programs that Azure has for some more credits. If you're interested in exploring it, there are ways to Azure services free as well. But it doesn't have to be Azure. It can be Google, it can be AWS, it can be all other various backup options. that you can have, and some of them might be cheaper or serving different purposes. All right, so one last thing I want to show you is that we can list the same content of the data using the AZ command. AZ command line is an Azure command line, and I am essentially listing here the content of my blob storage, which should result in the same output as we just seen on the web interface. All right, so that was Rclone, and let's actually delete everything there. Make sure that we clean it up since we don't need this demo. And as you expect, if we run the command 3 on Azure Backup, the folder should be empty, and this is the case. That works well. Let's move to last tool I want to talk about, which is Rsync. Rsync, you can think about Rsync as really a versatile CP or copy command. It can copy commands, it can copy files locally, it can copy it through SSH, you can use it from remote shell. There's all kinds of options. I think Rsync has the most amount of options I've seen at any command. There's a lot of flags. There's a lot of options you can learn and use. What is very important for Rsync is a so-called delta transfer. This is an algorithm that makes sure that you are sending only incremental data. So if you have a big folder with lots of files, several gigabytes of data, you back it up once, and then you use Rsync to synchronize. That's why Rsync. You're synchronizing your source data with the target data. Let's say you changed a few files and maybe you added two. Rsync will only move the delta, the difference between the source files and the target files. So very, very interesting. You can also use it as a replacement for your copy command locally. So very versatile tool, and definitely highly encourage learning about it, even outside of the context of backups. So what we're going to do now is to create a folder, which we will pretend it's a remote storage for Rsync. So having this folder, we can now run Rsync command. We are going to copy, we see a few flags AVZ. They actually do this delta transfer, and we are also going to see the output, verbose output of the command. So what we are doing, the same as previously, we are grabbing the demo folder and its content and copying it over to remote storage. So that should be easy. And as expected, we have our documents, doc1, doc2, image, and so on. They are all moved, or copied rather, to the remote storage folder. Okay, let's see if we can demonstrate this delta, which is the superpower of Rsync. First of all, we're looking into remote storage. All is as expected. We have the same behavior as with Rclone. There's no demo folder. We just have the content of the demo folder, source and document. Okay, now we are going to create a new file in our demo folder. Let's call it new doc. And then we are going to use Rsync to execute essentially the same command as we did. And we are expecting that Rsync now only takes this new doc because the other files didn't change. They are exactly the same. Rsync should take only our new docs. Let's see if it works. That's indeed worked. Rsync tells us that sending incremental file list, and the incremental file is only one, the new doc that we have copied into our demo folder. So let's make sure that this worked. And indeed, we have a new doc right here in the documents. So that worked as expected. All right, so that was a quick demo of 3 different tools that you can use to back things up. And let me show you how this can be put together in a backup script. So here we have a backup script. This backup script is really the idea behind it is to take all the tools that we've learned about and make them work for your specific use case. So we have here typical script. I am logging everything to a log file. Then there are some various simple checks here. whether the log file exists or whether we are currently maybe executing a backup. I am checking whether my NAS backup mount point is available before executing, since I'm actually mounting my NAS drive through an NFS. Again, there's probably going to be another video in the future. Let me know if you're interested in how to mount Linux file systems, various protocols, and so on. This export display is specific to the X server that I'm using with my Pop OS, and it actually makes it so that the script that is not executed from an interactive shell, but rather through a process, can actually interact with the X server, with the desktop, and this will become important at the bottom here of the file. So now we are creating the log files, creating the log files as well. And here we are cleaning it one more time. I want to make sure that the backup file doesn't grow. It's just for me to see whether everything worked as expected. And here come the rsync options, famous rsync options. I am actually reusing them since I have captured them here in an array. And those are various options I applied here. Notably, I have this delete options that is quite dangerous. But for my case, if the files are removed locally, I don't really need them in my backup. So this option takes care of removing the files that Rsync is using. And there are other options here as well. All right, so the first step in my backup script is to output a date, and then we are creating essentially a log script here. You can see that I am encapsulating everything in square brackets. This means that all the commands are executed together. They are all executed together, and they are all going to be output together, as opposite to being output one by one. So now, executing first rsync command, backing up system files, rsync options, which will render to this list of flags, and then I'm using an exclude here. So this is a very important rsync feature that enables me to tell which folders I want to include and exclude from my backup. So this backup pattern simply is just a list of folders with pluses and minuses that include them or exclude them respectively from my backup. So this is going to back things up to my mount point, which is MNT, NAS backup folder, and home. And not all the folders, but selected folders from my home directory are going to be backed up through this process. I am also backing up cron jobs. So here you can see this section here. I'm backing up cron jobs. The reason why I'm doing it is because I use a lot of cron jobs, and if I would lose my system, then I don't have an easy way to recreate them. I don't want to put them in my dot files, so that's why cron jobs are backed up in this way. Another one is backing up system files, so systemd specifically. So those are services. If you use Linux and you are using systemd, then you know those are the system services, and I keep there all my services. I use quite a lot of them for various automations. Similarly, I want to have them backed up. If I lose my system, I want to easily be able to recreate them. You can see here I'm using OBS for recording this video, and I have a quite few settings in OBS, filters and so on, and I want to back them up as well. So this is Rsync. Now we are moving to Restic. For Restic, I am backing up quite a few environmental variable files. I'm using direnv. I made a video about it a while ago. Very interesting tool for loading environmental variables depending on which folder you are. And here the setting at the bottom that we talked about, that I am only using one snapshot of Restic. I probably should use two in case the first snapshot is corrupted, but that's the setting. Let me change. So I'm going to use two snapshots, and this will give me a little bit more peace of mind that if one snapshot is corrupted, then I have also another snapshot in Restic to do it. Some specific settings here that are very specific to GNOME. I am using dconf, which is a command line tool and a database that holds GNOME settings, and I'm essentially dumping all the settings, all my Pop! OS settings, which include key bindings and various settings of GNOME programs, so I don't have to remember about it. It's super convenient in the specific use case of using Pop! OS or GNOME. And that gives me backup completed successfully message. And here at the very bottom, once everything is okay, I am using Dunstify to show me a message that everything worked well. And also here is a little bit added benefit of displaying the backup file. So Dunstify, if you don't know, it's similar to, it's essentially a system notification program. I believe it only works on Linux, but I'm not sure. It would work anywhere else. Definitely there are other options in different operating systems. So let's see if our backup would actually work. So we can execute backup like this, backup.sh, and now everything, all the commands that you've seen earlier are being executed, and we can see our Dunstify here. And now I am opening my log file, and all the backups have been successfully executed and created. All the snapshots will be created. You can see that we have this setting keep 2 snapshots, which we've just done, and now everything is all well. All right, great. So that was very quick introduction to various backup methods. Let's talk quickly about best practices. So very important with those type of tools to test. So take something small, like I showed you on the demo, create a little folder with some data and play around with it. Make sure that you understand the flags. Make sure that you understand, especially the flags that documentation marks as dangerous or important, like delete in Rsync and so on. So that's just to be safe, because it's your data. You don't want to accidentally delete something and then instead of backing up, you're just gonna shoot yourself in the foot. So definitely test it out. Spend some time understanding and learning the tools. Another point I mentioned earlier, always restore. So the moment you back something up, if in this playground environment, immediately restore to learn how the restore process works and to actually make sure it works exactly as you expected. This is the number one problem with the backup process that people do, whether it's private or in work settings. I've seen multiple times that the backup process is there, but nobody ever did actual restore. So definitely give it a try and make sure it works as expected. Finally, backup your backup. So backup your backup scripts specifically. This backup script that I've showed you is part of my dot files, and you should definitely have it backup, because this automation in and of itself is something that will be painful to recreate if you don't have those scripts. It's not data, but it's important anyway. And always use encryption solutions to encrypt sensitive data. I mentioned 2 options. You can use Restic if your data doesn't require extremely sophisticated encryption or strong encryption. And you can use things like GPG or dedicated encryption mechanism to encrypt your data prior to backing it up, which would be just another step before a backup. So some resources. Obviously, we've pulled some info from man pages throughout the demo. There are some resources on Rsync, and if you are confused with how to create front up, there's quite a few online resources helping you understand the cron up syntax and making your script executable. I'm going to show you cron up just for completions. So cron up E. At the very bottom, you can see here, I have the backup script that you've seen, and I have another command that is an rsync command that backs up my system, which runs at 1 o'clock p.m., which will be almost in an hour from now, every Saturday. So this is a very simple full system backup with Rsync. All right, that's all, folks, for today. I hope you enjoyed the video, and you will take some of the tools with you under your tool belt, set it up at home, and I definitely encourage you to think about backing up your system data. Spend some time thinking how you want to do this, where you want to back up, and definitely implement it today, this week, because you never know, things happen all the time. Disks fail. You can, fat finger something in Linux and delete your root partition, or all kinds of disasters can happen. So you will thank yourself later. Having backups and, of course, use command line tools make this process way more fun to work with, more portable, more interesting. All right, as always, thanks for watching. Let me know in the comments whether you are using maybe other tools or have some war stories from failed backups or issues with the data that you had yourself or you've heard about, as a warning for all those people that don't take backup seriously. Thanks for watching and see you in next video.